In this video, you're going to find some tips and tricks for solving compound inequalities when you get funny answers. So let's go ahead and look. We're not actually going to solve inequalities in this video. We're just going to look at what you might get when you solve them. So let's look at our first example. Here's your problem. It's two inequalities joined by and. You solve this one and you get x is less than -2. And over here you get x is greater than or equal to 2. My advice is to always graph. If x is less than -2, it's going to be an open circle pointing this way. If x is greater than or equal to +2, it's going to be a closed circle with an arrow pointing this way. When you are solving and inequalities, you're looking for the overlap. Here, there is no overlap. There's no number that fits here and here, so this has no solution. Let's say you solve another and inequality, and you end up getting x is greater than or equal to 2, and x is greater than -1. You're going to graph those two solutions. We have -1, 0, and 2. You're going to graph x is greater than or equal to 2, which looks like that. X is greater than -1, which looks like that. Since this is an and inequality, we're looking for where they overlap. They overlap starting here. And so here, the solution would be x is greater than or equal to 2, because that is where the overlap is. If this was an or inequality, so if we got rid of all of this and changed this to or, we would have x is greater than or equal to 2. Whoops. Greater than or equal to -1, and it would be or. So it would be either place. There doesn't have to be an overlap. In that case, this would be your answer, because then it fits one inequality or the other. You might have other instances where you solve it and you get x is less than 3 and x is greater than or equal to 3. Of course, if you graph that, you've got 3, we've got less than 3, we've got greater than or equal to 3. Since it's an and, there's only, actually there's no overlap because it wasn't less than or equal. So this one would be no solution. However, if that was an or inequality, that would be all real numbers, because all real numbers fit in either one of those inequalities. Okay, so the trick here is to always graph and then look. If it's and, you're looking for overlap. If it's or, you're looking for anywhere that it fits either inequality. Hope that helps. Good luck.